Good night, everyone. Wastewater treatment processes. So let's see what's happening inside a wastewater treatment plant. So this is a very basic schematic of a wastewater. After a screening and rechamber, the incoming sludge uh, comes to primary tank and almost like by 25% to almost 40% of the material are settled, pollutant are settled here, and then it just moves forward to the secondary one, and we can have like aeration tank in between of them. Then it just moves like part of it going out. We call that effluent. Part of it's wasted, moves out of the system, and a part is recycled and it just moves and we put air to a sludge, and this is the domain of activated sludge zone. So we keep them like in an active process and recycle it by the amount of initial one plus recycle, then move to secondary to increase the efficiency of the system. So let's see what's happening exactly there. The organic material in the incoming wastewater constitute called the food, and that's a equation for that. It's food is equal to S naught Q naught. In an S naught is usually taken as the incoming BOD 5. 5 stand for 5 days, and that's biological oxygen demands, which is like a food to the microorganism inside the food. And Q naught is the flow of the wastewater. And the mass of microorganism, capital M, is determined from the volatile suspended solid concentration in the sludge. And that's a capital M is equal to volume of our tank, settling tank, either primary or secondary, times a X sub A, which is the concentration of activated sludge. So that's mainly in terms of MLVSS or ML, sometimes MLSS, mainly MLVSS. MLVSS stands for mixed liquor volatile suspended solid, and that's mixed liquor volatile suspended solids, and MLSS is mixed liquor suspended solids, but not the volatile one. But mainly that's the volatile part. And let's put it into an example to see how it works. And then F over M is food over microorganism, and that's like the S naught concentration of BOD times incoming flow over the volume of our tanks times concentration of activated sludge. So put it into an example. In this example, we do have 770,000 US gallons of conventional activated sludge process, which has a recycle ratio of 0.25, and the coming flow rate is 1 mgd, stand for million gallon per day, and a mixed liquor volatile suspect MLVSS concentration is 700 mg per liter, and in S naught, which is BOD5, is equal to, that's our S naught, and that's equal to 160 mg per liter. We want to know what's F over M, what's the ratio of food to microorganism in our wastewater planet. Let's see how we can solve this problem. So F over M, food over microorganism, is by the definition food over microorganism, and by formula S naught Q naught over capital M, which is the volume of our settling tanks times the concentration of activated sludge, which for in our case that's a mixed liquor volatile suspended solid MLVSS. That's mainly in terms of the volatile material in the solid part of a sludge. And if you put it into numeric value, S naught is 160, which is BOD5, that's our S naught, and 1 mgd just 1 times 10 to 6 US gallon per day, and our tank volume, settling tank volume, 770,000 US gallons times concentration of mLVSS. And if you do so, it just gives you 0.2968, almost zero point 0.3. And that's like if you just round it up, it's zero point 0.3 per day. Thank you will solve more problem in uh, activated sludge.